Well, hello everyone, and welcome to part 3, part 5, part 3. So, in parts 1 and 2, we made histograms directly using the histogram chart tool, and then we made a histogram off of a pivot table. And now we're actually going to do a histogram our third way, which is making a histogram off of a formula. And all three ways are important, and all three come up in real life. One tends to gravitate towards the one that you like the best if you can use it, but it is important to be familiar with all three. Okay, so we're back to the 50-10 formula data set. And as far as the part at the top, again, that's going to be the same as you did over here in the 50-10 histogram and the 50-10 pivot, so you can do that on your own. What's new down here is the frequency distribution that you're going to make using pivot tables. So let's go ahead and start there. So here we're actually manually creating these lower bounds and upper bounds. So as we typed these numbers, lower bound and upper bound. And most of them make total sense, except for the first one and the last one. So I want to talk about the first and the last separately. So you'll notice that we go from 22,000 to about 26,000. So these are 4,000 intervals. But for the first one, the interval is much greater because the first one encompasses anything from 0 to 22,000. And then the last one's different because we have to account for the fact that we might in the future get a really big salary. So we basically have to go from a lower bound, and then the upper bound is effectively infinity. And that's actually going to change what this formula looks like for this guy. For all the other guys, the formula is going to look exactly the same, but this last one is going to get a different formula. So let's get to it. First of all, this, well actually I'll come over here because it's going to be the frequency formula. I'll come back to this combined. This is just what we're going to use in order to graph where we have to actually put these numbers together, so they'll appear on the graph together. But let's talk about the frequency distribution first. So this is going to be our count ifs formula. So count ifs, the criteria range here, lock it, and the criteria is that this is actually very similar to what we did with all the standard deviations where we had these ranges, so that the knowledge that we get from that's going to come in real handy here. So it's going to be the greater than or equal to and the quotes, and then ampersand this lower value. Okay, and that same criteria range, which we'll lock, has to be, in quotes, less than or equal to ampersand the upper value. And what's great about that is because we've locked these ranges, we can actually copy this formula down to everyone except the last one. So we're going to stop short of the last one. And now we need to go ahead and force grading so we can actually see that happen. And we're unhappy with the formatting, so let's do comma format and then grade again. There we go. Okay, now the last one, I'll copy the formula into the last one, but it's not going to work. And the reason it's not going to work is because we're trying to say less than this word infinity, but that kind of makes no sense. So it's going to be really unhappy when we grade it. And the solution is very simple. We simply take off the end of the formula. We don't check for the upper bound, just the lower bound, just greater than the lower bound. And it can be, an upper bound can be anything to infinity, like to infinity and beyond. All right. And so now it comes out right. Grade it again. Okay, and then we'll add up all those frequencies using the sum. And then we'll get the percentage by taking each of these numbers, dividing it by this as an absolute reference, and then formatting it as a percent. Copy that down. And then we get the cumulative frequency. Remember, this is one where the first one's different than all the others. So the first one is just the first one over here because there is nothing above. But then the next one and all the rest of them are going to be the one above because we're trying to create a running total plus the one to the left. And the reason both of those are the same is because that was a 0. But as we copy it down, grade, we'll get to 100%. And the last thing we need to do, right up here, get the 100%. Okay, so everything's going well. This combined thing, this is just so that we can get these ranges appearing on the graph as a single range. It's going to make it easy for us to graph. So we'll simply say that's going to be this value, ampersand, and then we need to put in quotes, space, dash, space, then another ampersand, and then this value. That gives us our range. We'll double check it on grading. Okay, now the reason we did that last bit, is just so that when we go to graph, we can grab these two fields to graph, and this will be what labels the bars. And there's our graph. Okay. And the title of this one is 50-10 salary distribution. And so that's how you get your kind of quasi-histogram. I say quasi because this is technically a column chart. In fact, let's go ahead and answer that. So this is a column chart. One data series and 50-10 salary distribution. None. None. Grade. Okay. All good. Now we'll do the same thing with the 52. So again, top part's the same, so you can get that from one of the prior videos. And then we come down here to the formula distribution. Notice that we picked different sets of numbers here because remember this is with the 52. Everybody's close to the mean, so they're all packed in around 50,000. So we're going to start here at effectively 0 to 46,000. So we do the count ifs again. Lock it, because we actually want to copy this. And then we're going to be greater than or equal to ampersand the lower bound, which is this one, the 0. And then we'll do the same range. Locked. As less than or equal to the upper bound, which is this one. Copy that down. So that one's formatted. Right, and so it's all correct except for the last one. Remember, the last one we have to drop off the upper bound because it can go all the way to infinity. So we take out all of that piece. Great again. We're all set. Oh, then let's get the sum. And divide each by that. There's a locked reference. And a percent. Then the cumulative, remember, for the first one, it's just the first one. And then for all the next ones, it equals the one above plus the one to the left. Copy that formula down. Great. Add this sum that we missed. And then do this combine thing so we can graph. So that's going to be equal to this guy combined with a space dash space in quotes combined with this guy. Copy that down. That's going to give us our labels for the bars. And then we can make our graph. Insert. There's our quasi-histogram. And change the title. Then answer the questions. I'm sure by now you know what the answers to these questions are. So I'll just make sure that I do the graph title just in case there's anything funky there. Yeah, looks like that's right. Okay, so you can do the rest. So just in review, what we've looked at in all of these three parts of Prep 5 is here we looked at generating a histogram directly off the raw data. That's by far the easiest thing to do. And then we did that with 5010 and 52. Then we looked at, well, what if the distribution is skewed? That's a big deal, and it turned out that if the distribution is only slightly skewed, you can still use, you can still fit a normal distribution to it, and the properties in normal distribution seem to hold. But in a skewed distribution, you should report the median rather than the mean as the central tendency, because it doesn't balance perfectly. The balance point is kind of more over here than directly in the middle. And then on the pivot table, what we did is we created a pivot table directly off the raw data and then graphed off of that. And then we used this feature to very quickly get these intervals in the pivot table. We did that for 52 also. And then when we got to the formula, we made the intervals. And one of the advantages of making the intervals yourself is that you can have some bigger than others. So for example, this first one, we can make really big, whereas when it generated the intervals for the pivot table and even for the histogram, they were all exactly the same size. So this gives you your most control, but it's also your, in a way, hardest and more time-intensive distribution to do. So the other big concept that came out of this unit was the idea of the empirical rule, which says that 68, we have a normal distribution, 68% of your values are within one standard deviation of the mean, and 95% are within two standard deviations of the mean. And we actually saw that the empirical rule really held for all of these distributions. So I hope that standard deviation after this unit has some meaning, some real world practical meaning to you, as opposed to just something that you learn how to calculate in school. And we'll see you for the next video.